So we'll be starting a new chapter this week. This is by far the largest chapter on GCSE Maths. It covers everything algebraic, but this week we're going to start off with some simple linear equations. So a lot of these things we're looking at today I think you'll have seen before in year 7 and 8, and actually during this year as well. So I want to point out, I guess, the key points and just sort of skip through a lot of different types you can get and hopefully point out some equations you maybe haven't considered before. There are three big rules for equations, and this first one is by far the most important, that whenever you're solving one of these, you've got to do the same operation to both sides. If you're going to add 7 to one side, you need to add 7 to the other side. That's because the equal sign is saying this is a thing on the left is the same as this thing on the right. So if we add 7 to both of them, well, they're still the same. It means we can keep using the equal sign. This is maybe a point that we wouldn't previously have used, but we did rearranging to make things the subject earlier in the year. And that checklist of things that you do, that method, that multiply, expand, collect, factorize, divide, that still works here. So if you're never really sure what you do first in an equation, that might be a way to deal with it. And this third point, you do get told early on and people just tend to forget about it. But if you're not sure about your answer, you can always check it. You can always take your value of x and plug it back into the equation. Now I'm not going to do these with all of these examples, but I want to do it with one or two just to point out, I suppose. Anyway, so we've got here three equations that we should be able to do. Let's try and do it using those rules. So we've got 8x minus 3 is 37. Now the first thing we're actually going to get rid of is the minus 3. We want to remove things that are not touching the x first, and we're going to do that by adding 3 to each side. Now when we say adding 3 to each side, we're going to add it to the numerical parts of the equation. We're not going to turn this 8x into an 11x. So we'll end up with 8x is 40. And then we're saying 8 times something is 40. So if we want that thing, we need to divide everything by x. So x is 5. If we wanted to be sure if we were right, we could then go, okay, so 8 times 5 minus 3, is that 40? Yes. If you're encountering a bracket, if we're going through the method thing, we should expand those brackets. So if we do, we'll get 6x minus 18 is 48. Then it's the same as what we just did. We're going to add 18 to each side. So 6x is 66, and then we're going to divide by 6. So x is 11. So the last one, a couple of ways you can do this. I think a lot of people would maybe take away the 7 first and then double, and that's fine. I'm going to show you where you could do it another way though. We can double everything on each side, and if we do that, the x over 2 will just become x, and the 7 will become 14, and the 13 will become 26. And then we can take away the 14 that we've got there, so we'll end up with x equals 12. If you were to take away the 7 and then double, you'd end up with 12 as well. There's normally just not one correct way to solve an equation, as long as you're doing the same operations to both sides of it. Now that first page was around about grades 3 or 4. X on both sides is a grade 5 sort of linear equation. And all you've got to remember is to subtract x from one of the sides. Now, you can obviously choose which side this goes on. It's normally a sensible idea to collect the x on the side that's got the most positive x. So we want to collect them on the left in that first question. We want to collect them on the right. We want to collect them on the right. And well, we'll have to see what that looks like when we expand it. Reason for this is it just means you'll have to divide by positive numbers rather than negative numbers. It's purely a stylistic choice, but it's one that results in less awkward maths. So try and move the x to the side with the most positive x. But anyway, we'll do the same as what we did. We'll subtract 6 from each of them. And again, notice I'm not touching the x here. I'm subtracting numbers from numbers. So that'll give us 2x plus 21. And then we'll subtract 2x from each side. And that'll give us 3x is 21. Finally, divide by 3. And we'll end up with x equals 7. You could check if this works. We could go 5 times 7, so that's 35, plus 6, 2 times 7, so 14, plus 27, and yeah, both of those equal 41. Okay, you may as well have a go at the next three yourself, to be honest, but I'm going to assume that you're pausing the video now, and you're coming back in 3, 2, 1. Okay, so here we are going to subtract 2x this time. And that'll give us 14 is 4x plus 4. Notice I've subtracted the x first, doesn't make a difference. Then I'm going to subtract the 4, 10 equals, I should say 2x, shouldn't it? 10 equals 2x. and then we divide by 2. So we'll end up with 5. Let's write that in, divide by 2. We'll end up with 5 equals x. So we reckon 5 is a solution. 10 plus 14 is 20 plus 4 is 24. Yeah, that works. Here we're going to start by adding 4x to each side. So we'll have 15 equals 5x plus 10. Take away the 10. 5 equals 5x, and then divide by 5, and we'll end up with x equals 1. I do want to emphasize it's not necessary for you to actually write down these steps when you're doing the work for yourself. It just helps make it obvious what method you're using. But if you want to jump straight from the first to the third to the fifth line, that's absolutely fine. Lastly, we've got some brackets, so we should expand them first. So 6 minus 16x is 9 minus 18x. Which one of those is more positive? Well, this one just about. So just be careful with your signs. So the first thing we're going to do is add 18x to both sides. That'll give us 6 plus 2x is 9. Then we're going to take away 6, so 2x equals 3. And then we're going to divide by 2, so we'll end up with x equals 1.5. Or you could write it as 3 over 2. Now, if there's fractions in the questions, we want to look at the m of Mechford and we want to multiply everything by those fractions. So here we've got a 3x minus 2. We're going to multiply both sides by 3x minus 2. Now, what's that going to do? Well, let's do this the long way once, and then probably just use the shortcut from now on. If we multiply this by 3x minus 2, so that will come on the top of the fraction, and we multiply this by 3x minus 2, what will happen is these two here, just change pen, will cancel out, and we'll just end up with 5 is 8 lots of 3x minus 2. Now, what people tend to end up remembering is that if you've got something on the bottom of a denominator here, you just move it here and it becomes a multiplication, but that's why. Your times in the top of that fraction is cancelling out with the denominator that's already there. Once we're here, well, we can do the same sort of thing. We can expand our brackets, so 24x minus 16. We can add our 16 across. I think I might stop writing down the steps individually here, and we can divide by the 24. Now, that looks awkward, 21 divided by 24, but you're actually allowed to just give an answer as a fraction. If it's me, I probably want to simplify that fraction, divide top and bottom by 3, but that's what I'll go with. Okay. What about the second one? Well, here we've got 2 different fractions, so we kind of need to do this in maybe 2 steps, I suppose. So we're actually going to multiply everything by 3 and multiply everything by 4. Okay, so what's that overall? That's the same as multiplying everything by 12. Reason we're doing that is it's going to get rid of all the denominators at once. So let's do that top and bottom. So 12, well, top only, 12 lots of x minus 2 over 3 plus 12 lots of x over 4 equals 24. Don't forget to multiply this last number as well. Okay, this looks awkward, so we'd want to simplify it. We could do 12 divided by 3 on this first one, so to just give us 4 lots of x minus 2. We could do 12x divided by 4, that'd just be plus 3x. And we could divide, well, there's nothing there, so that's just 24. So that's just tidying it up. We haven't actually done anything there. Then we've got brackets, so we should expand them. 4x minus 8 plus 3x is 24. So we're going through the full method here. That was m, that was e. Now we're going to collect our terms. We're going to have 4x plus 3x is 7x. We're going to add the 8 to the other side, so 7x is 32. Nothing to factorize, so let's divide. And again, you can just leave it like that. You don't even have to put that as a mixed number. In fact, I'd say it's worse to put an equation answer as a mixed number. They're just harder to work with. So 32 over 7 is what we've got. What about this one here? What are we going to multiply this by? Well, we could think about multiplying it by 4 and by 6 and by 3, which is like 72. That's definitely an option. But if we multiply things by 6 and 3, they're both going to cancel out as well. So a cheaper way here would be to multiply by 6. By 24. Multiplying just by 6 and then by 4, because we know if we multiply by 6, that'll get rid of the 3 as well. In fact, I think you can be even smarter than that and multiply it by 12. We're essentially trying to multiply by the LCM of the 4, the 6, and the 3, and they all go into 12. So yeah, that seems sensible to me. So we'd end up with 36x over 4 plus 84x over 6 equals 12 over 3. We then want to simplify it, so we'll go 9x plus, I think that's 14x equals 4, 23x equals 4, and then we can divide by the 23, so we'll end up with x is 4 23rds. Again, no further simplifying necessary. So yeah, if you've got denominators, you just need to multiply to get rid of them before you do anything. Okay. One special case of this is where you have a fraction equals a fraction, and we can use something called cross multiplication to shorten this process. I'll just show this long form so it's obvious what I'm doing. Here, I'd be looking to multiply everything by x minus 1 and to multiply everything by 2x minus 1. That would get rid of both the denominators. So I could have something like 3 times x minus 1 times 2x minus 1 all over x minus 1 is equal to 9. I need x minus 1 and 2x minus 1, and then we could cancel some of the stuff out. We could cancel out those and those, and we'd end up with 3 lots of 2x minus 1 is equal to 9 lots of x minus 1, and that's great. That's really complicated, when what we can do instead is we can just use this little cross multiplication shortcut. If you've just got fraction equals fraction, we can draw a cross, and we can just multiply those two things together. So I'm going to multiply my 3 by my 2x minus 1, and I'm going to multiply my 9 by my x minus 1. And yeah, I end up with exactly the same thing. So that cross multiplication thing is a really nice little shortcut when you've got this situation. After that, we just obviously expand, collect. So we're going to take away 6x. It's going to give us 3x here. We're going to add 9. We're going to divide by 2. This might be a situation where you want to check if it works, so we could. That would give us 3 over 2, and this would give us 9 over 3. Oh, sorry, 3 over 1. 9 over 3, and yeah, that works. Okay, so maybe you try the next one. And come back. So we've got 5 lots of x plus 7. Again, I'm going to cross multiply, so 5 times x plus 7. And 3 lots of 2x minus 4. So that will give us 5x plus 35, 6x minus 12, take away the 5x, so x minus 12 is 35, add the 12, 47 equals x, and done. Again, you could check that saying 54 over 3 is equal to 90 over 5, and yeah, they both equal 18. Okay, last one, same idea, cross multiply, 5 lots of x plus 7 equals 15 lots of x plus 5. So we've got 5x plus 35 is 15x plus 75. And then take away 5x, so 10x plus 75 is 35. Take away 75, so minus 40 is 10x, divide by 10 minus 4 equals x. Cool. Now you can also do some application of these equations where they'll give you some sort of shape setup or some sort of wordy setup and ask you to come up with the equation in the first place. Now this isn't going to be too complicated this week because we're on linear equations. You really need to get into like areas and quadratics for this to be properly awkward, but let's use this as a sort of starting point for it. So all I've said is you need to pick out the relevant fact from the question. It's going to be to do with angles or perimeter or possibly area at this stage. So in this question we're told the perimeter is 30. Perimeter is the distance all the way around, so we should make sure that we know the distance is all around. That's actually 2x plus 6, and that's another 5 minus x. We're assuming this is a rectangle. Question is, what is the area? Well, we need to set up an equation. We know that the perimeter is equal to 30, and we also know the perimeter is equal to all of these things added up. So it's the 2s plus 6 plus 5 minus x plus 2x plus 6 plus 5 minus x. Collect your terms together. So we've got a 2x and a 2x, that's 4x. Take away an x, take away an x. That will give us a total of 2x. And we've got 6 plus 5, 11, plus 6 plus 5, 22. 2x plus 22 is 30. Take away 22, divide by 2. We can get x is 4. And then we actually want to find the area. So this is maybe a point where you'd sub it back in. We've got the length here is 1, 5 minus 4, and the length here is 14. So the area is just base times height, 1 times 14, 14 meters squared, because it tells us units in the question. You could also get something to do with angles. Now this is an isosceles triangle, because it's got these two little lines saying they're the same. And it's saying the equal angles, so that's these ones, are 10 less than double the third angle. So the third angle was x, and double the third angle is 2x. And 10 less than that is 2x minus 10. So what this is telling us is that these two equal angles here are both equal to 2x minus 10. It says our actual question here is to find each angle. Now what else do we know about triangles? Angles add up to 180. So that's equal to our x plus our 2x minus 10 plus our 2x minus 10. Same thing we did then, collect our terms together. That's 5x is there and 20 is being taken away. So add the 20, 2x to 100 is 5x, divide by 5, 40 equals x. Find each angle though. So we need to substitute that in. So our angles are going to be just x, so that's 40. And then 2x minus 10, so that's 40, 80 minus 10, 70, and 70. Do they add up to 180? Yes, so that's a good check you can do. And they work obviously for the x we found. Have a go at these two yourself first. I'm going to unpause in 3, 2, 1. Cool. So your angles again add up to 180 in a triangle. That's 3x plus 60 is 180. Take away the 60, divide by 3, and then find the largest angle. So this is an 80, a 40, a 60. The largest is just equal to 80. These are the same area. These are trapeziums. And the formula for the area of a trapezium is a over b over 2, a plus b over 2 times h, where we're talking about a and b being the two parallel sides, and h is the perpendicular height. So if these have the same area, we need to set up that equation. So for the first trapezium, a plus b, so we've got x plus 2, that's our a, plus 3x plus 1, that's our b, all over 2, times 5. And that's going to be equal to the same thing for the other trapezium. So it's going to be equal to 2x minus 1 plus 5x minus 1 all over 2 times 7. Now that looks horrible, but we can try and tidy it up. So let's add the tops of our fractions together first. That's going to give us 4x plus 3 over 2 times 5 is equal to 7x minus 2 over 2 times 7. What would you do next? I might multiply first. So multiply and division doesn't really matter which order you do it in, but I feel like getting rid of that multiplication, so let's do that. So we've got 20x, let's write my x's the same way, 20x plus 15 over 2 is equal to 49x minus 14 over 2. Then we've got ourselves a cross multiply, so let's use that. We'll have two lots of 20x plus 15 is equal to two lots of 49x minus 14, and that will give us 40x plus 30 is 98x minus 28. Okay, let's carry it on over here. So we've got 40x plus 30 equals 98x minus 28. I need to take away the 40x, I guess. So I've got 30 is 58x minus 28. I need to add the 28, so 58 equals 58x. Divide by 58, so x equals 1. Actually need to find the lengths of each side though, so let's fill them in. That's 3, 4, 1, and 4. And it's always pleasing when you get a nice answer at the end of this. If that had been like 1376, I would have been really annoyed, justifiably. Now the setups obviously don't have to be shape. They very frequently are, but they don't have to be. They can just be something wordier. And the general key with these sort of questions is to just decide what x is going to be and then manipulate it in the way that the question wants you to do. So here we've got I think of a number. Now if we're told that in an maths question, I'm immediately going to say, well, that number is x. We're told that we take away 3 and divide it into 11. Okay, so take away 3 from it and divide it into 11. We're not dividing it by 11, in which case 11 would be on the denominator there. We're dividing it into 11, so we're doing 11 divided by it. Okay, great. This gives the same answer as when I take the same number, x, and divide it into 8. So again, we're dividing x into 8. This gives the same answer, so that means that these two things I've worked out are going to be equal to each other. Aha! We've got our equation. And it's a cross-multiplying equation, even better. So we're going to multiply across by the x, and we're going to multiply across by the x minus 3. Question is, what is the number? So we're trying to find out what x is. So we'll have 11x is 8x minus 24. Take away 8x. 3x is minus 24. Don't lose the minus. Divide by 3. X is minus 8. It was minus 8. And you may as well check it at this point, mightn't you? Think of a number, take away 3, that's minus 11. Divide it into 11. So 11 divided by minus 11 is minus 1. Same answer as when I take the same number and divide it into 8. 8 divided by minus 8 is equal to minus 1 as well. So yeah, it works. So this one's a fairly common GCSE question where they use the concept of the mean. Now the mean, as we know, is equal to the total of everything, the sum of everything, divided by how many there were. So divided by the frequency. We did that back in chapter 20 a few weeks ago. So what we need to do is work out what all of these boxes added up to. We're told the mean value of each box is equal. So what does box 1 add up to? Well, let's just collect the terms. 2x and 3x and 5x and 7x. Well, that all adds up to 17x. Minus 1 plus 2 is 1, plus 4 is 5. So that total is 17x plus 5. Box number 2, you can do the same thing. I'd maybe not bother with 2 lots of 3x plus 1 and just expand that and say, well, that's 6x plus 2. Let's add these up. So we've got 3x plus 6x, 9x minus x takes us to 8x. And then we've got minus 7 plus 13, that's 6, plus 2 is 8. Cool. So that's our sum. About our frequency, how many are there? Well, there's 4 things in this box, 3 things in this box. So sum over frequency, and the mean value of each box is equal, so these two are equal to each other. What does that mean we've got? It means we've got another cross multiplication. So let's do it. 3 lots of 17x plus 5 is equal to 4 lots of 8x plus 8. Expand. 51x plus 15, 32x plus 32. Subtract 32x, so 19x plus 15 is 30. No, it's just 32. Take away the 15. 19x equals 17. And then divide, so we've got x is 17 over 19. And again, you don't have to do anything with that. Simple enough. Fair enough. Last question, the old guess my age situation. In 10 years, my age will be double what it was 11 years ago. How old am I now? So this is a question where you need to come up with a variable yourself. And I'm going to say my age now is equal to x. So in 10 years, that would be x plus 10. 11 years ago, I would have been x minus 11. So what have we got? In 10 years, my age, which is x plus 10, will be double, will be twice as much as what it was 11 years ago. 2 lots of x minus 11. And that's it. That's the equation you've got to set up. Read through the sentence in order and just replace every bit that mentions your age with some algebra. So from there, fairly straightforward to solve. We'll expand. We'll subtract x from each side. We'll add 22. So it turns out I'm 32 now. And this would be a good case to check. In 10 years, so I'll be 42. My age will be double what it was 11 years ago, 21. Yeah, that works.